So, good morning. So, today we talked about time series graphs. So, today we will talk about something called box plots. Have you heard of box plots? Anybody? This is a very important way to represent the data using some numbers. This is also called 5-point graph, okay, also called as 5-point graph. So, points are you have median, okay. So, the 5-point graph is composed of median. You all know how to calculate a median? Everybody know how to calculate a median? Yes or no? How do you do? Arrange in ascending, sort in ascending order, and then pick out the middle value. If it is odd number, it is straightforward. If it is even, you have to take the average, right. So, that is median. So, you have the median as the center line then, okay. So, you have median as the center line. What is LQR? What is that? So, you have sorted the data in ascending order, right. So, lower quartile range is what? From 0 to 25% of the data value, 0 to 25 range. So, there is a whole range, right. So, 0 to 100%, you know what is a range? Range is the max minus min. So, range is nothing but okay. So, now you have 25%, that is nothing but your lower quartile range. Okay. And what about UQR is upper quartile range, which is nothing but your 75%. This overall is now but nothing but 50% of the data lies within this range. So, that is an important number for us, range for us. How is the spread is known? I do not even calculate mean, variance, etc., but in this itself I will be able to get the idea about the spread, okay. Then what is min and max? Is it min and max of the data? This min and max is different, max minus min range is different from the min and max plotted in the graph. What is min max? We actually extend it up to 1.5 times okay. So, this is what typically we call it as min and the other one is max, okay. It is not min and max of the data, okay. So, what we call it min and max is nothing but you have the 1.5 times the lower quartile range and 1 times the higher quartile range. Of course, if the data lies within the 1.5 times LQR and 1 times the UQR, then this, what is this? This tail or the line extending will come down, okay. Now, you may have a data where a data set where it goes beyond 1 time 5 times. So, these are nothing but whiskers, they call this box plot also is called as whisker plot, box whisker plot. Okay. People call it as box plot or box whisker plot. This whisker plot is something but that extends, these whiskers are nothing but the extensions to the center from the 50 percentage. It extends at the maximum up to 1.5 times on LQR or UQR on both the sides, right. So, that is this is the box. Anything beyond this you represent it and this becomes outliers. You typically draw them, that is why it is, you typically indicate them so that it is clearly outliers. So, this is Boxcar plot or box plot or box whiskers plot. Make sense? You understand? So, this summarizes the data, this summarizes my data. Okay. So, this is why it is called 5 number plot, a very useful plot, because I know how much is the 50 percentage, I know the whiskers, and if the data is beyond whiskers, then you know that there are outliers to look for, a simple summary will give. So, now today we are going to just first look at, so far we have looked at graphs. Okay. Your friends will send you the spider plot and multivariate coordinate plots are there. So, that is what I thought. I do not know whether you have looked at coordinate plots. So, multivariate plot is called, there are multiple, you can look at even 10-15 variables at a time using what is called as coordinate plots. Spider plot is when you want to look at multiple variables and their typically their objectives. So, you take an environment sustainability issue, right. You want a product to be cost effective and sustainable. Is this competing objectives or is it easily achievable? Imagine an IC engine versus an EV engine today, right. So, imagine a low cost. So, in our case what is it? Cost effective but high accuracy. Is it possible? Is it not conflicting? Competing interest, right. So, cost effective means, so suppose I take ECG, I want to make it cost effective. What can we do? We are all biomedical engineers, at least you are all biomedical engineers. What is it you will do? Your reduce the number of leads. How many leads typically you need for an ECG? Minimum 3. It is a 3 lead ECG is enough, right. So, in fact, a 3 electrode is enough, 3 electrode ECG system is enough, but will you be can it be used for many purposes? In fact, a 3 lead ECG cannot be used for diagnosing heart attacks. Okay. We think of the rest of the 6 leads as not important to record what? The PQRS waveform, but it is not, it does not mean that it is not important. Okay. It simply means that to that record that PQRS activity, that is the the heart rate etc., you need only 3 leads, fine, but that is not the only information which a doctor looks for in the ECG. So, the other 6 leads kind of gives information about the blood flow to the heart etc. So, whether or not a heart attack has happened or whether somebody needs an immediate attention can be easily seen using the other information from other 6 leads. So, a 12 lead is a must for doing diagnosis of heart attacks etc., heart arrest or something. So, obviously we are trading off, if you reduce on cost. So, this kind of objective, so if you write in cost, accuracy, sustainability and many other stuff, all of them will be competing with each other. So, if you draw a plot of all these objectives, then it will start looking like spider, meaning one corner is sustainable, the other corner is what I say is cost, accuracy, then you can maximize on one, but you will be having a minimal on the other, right. So, it will start looking, so he will send you the plots, okay, it will start looking like spiders. So, these spider graphs are very useful in looking at objectives, multiple objectives in a single, multiple conflicting, especially competing objectives in a single graph, and then see how to go about it. Okay. So, spider graph, typically when you start drawing spider, you know that it is for looking at competing objectives. Okay, you will be sending, right. So, you will send it out. So, we have covered the various ways of representing data, starting from simple graphs, frequency distributions, histograms, Ogive plots, cumulative distributions, bar, pie, box plots, okay, spider, and then we look at multiple coordinates.